right, so we are going to learn about density today. Density is a physical property, so it does not change the bonds in a molecule. When you look at the density, when you measure the density, you're not changing any of the bonds. The chemical formula is going to stay the same. And it's also a quantitative property, which means we can measure it, we can describe it using numbers, right? Here you can see that different densities, different substances with different densities can be separated and also will float or sink. So honey is very dense, and so it's at the very, very bottom. And lamp oil or rubbing alcohol are not very dense, and so they are at the very top of the little column here. You can also see that there's a penny in here, there's a bolt, a ping pong ball, soda cap, beads. So you can see, oh, that's not a penny, that's a tomato. So you can see the different densities and where they kind of lie in this little spectrum shown on the screen. So density is actually the compactness of matter. Healthy bones are going to be very dense, and if you have osteoporosis, you're going to have less dense bones. So this is important for our medical folks as well as our scientists. Here you can see that a gas is going to be the least dense because the particles are the most far apart. In the same amount of space, a solid would have many, many, many more particles crammed into that space, and so therefore it's going to be more dense. The formula is going to be mass divided by volume. Divided by is per. Those are like the same thing. So what does per mean? It means divided by. So our formula is going to be density is equal to mass divided by volume. We usually measure mass in grams, and our volume is usually in milliliters. You can also have cc, which is a cubic centimeter. All right, so that's a centimeter cubed. Usually we'll represent the D, the density with D, the mass with M, and the volume with V. We can manipulate this 3 different ways. So if we have density is equal to mass divided by volume, we can multiply both sides by volume. The volumes here will cancel out, all right? And so you'll have density times volume is equal to mass. If I wanted to look for what the volume was, I would have to divide each side out by density. So I divide both sides by density. The density on the left-hand side cancels, and I get volume is equal to mass divided by volume is equal to mass divided by density. All right, our units of density are going to be either grams over milliliters or grams over centimeter cubed. A milliliter is a centimeter cubed is a cc. Those are all the same things. The density of pure water at 25 degrees Celsius is going to be 1 gram per milliliter. I don't expect that I'll have to give that to you. This should be a fact that you memorize. If you stay in the sciences, it doesn't matter what science you're in. You're going to be in biology. You're going to be in chemistry, whatever it's going to be. You're going to need to know that the density of pure water is about 1 gram per milliliter at 25 degrees Celsius. So less dense substances float above more dense substances, and I think this makes sense because they have less particles per area. Okay, so if you have oil that is 0.92 grams per milliliter, and then you have vinegar with a density of about 1.01 grams per milliliter, which do you think is going to sink and which is going to float? Will the olive oil sink or will the vinegar sink? Well, the vinegar is going to sink because it has a greater density. And so that's what's going to be on the bottom. Here you can see, like, this is olive oil and balsamic vinegar, and you can see that the balsamic vinegar is poured on the bottom. There's a couple different ways that well, for mass you have to just determine it using a scale, but there's a couple of different ways you determine the volume. Here you have a piece of jewelry. It looks like it weighs about 1.595 ounces. Remember that 5 is estimated. That last 5 is the estimated digit. So it's our digit of uncertainty. Using to find the volume, we need to use one of 3 methods. We can use a graduated, sorry, the D got covered up, graduated cylinder for liquids, where we would just pour the liquid in the graduated cylinder. You would measure how much it was. You would read that to a proper number of decimal places. You could also do water displacement. Here we have a container of water. If we knew how much water we had in there and we added a key, the key would actually displace the water. The amount that it displaced the water is the volume of the key. Or if you have regular size shape, sorry that letter got cut off again here, you would just measure each side and then use the formula. For instance, for a cube, it's going to be length times width times height, or for a rectangular prism, the same. So you would just use your measurements to figure out what the volume of the object was. Alright, so here we have an object with a mass of 6.25 grams and a volume of 8.60. What is the density? Alright, so for this problem you're going to need to write down what you know for a first step, write down and manipulate the formula for a second step, and then for the third step you're going to solve by plugging in the values, putting in your calculator. So what we had was a mass of 6.25 grams. We had a volume of 8.60 milliliters, and we are looking for density. So we know that density is equal to mass divided by volume. Okay, so since we don't need to manipulate this, we can just go to the next step because we're solving for density, and that's our question mark. So the density is equal to the mass, which is 6.25 grams, divided by 8.60 milliliters, which is the volume. You put that in your calculator and you should get 0.727 grams per milliliter. Notice that I kept my units. It's grams over milliliters. And that's it. So that's it for this one. We can go on to harder problems.